Hi friends, today we are going to discuss the topic known as phase lock loops. See, this PLL or phase lock loop is a feedback system which consists of phase detector, low pass filter, error amplifier and voltage controlled oscillator or VCO. These are the components of phase locked loops. Friends, first we will see the functioning or the working of VCO or voltage controlled oscillator. See, this voltage controlled oscillator is a free running multi vibrator which operates at a frequency f0, and this frequency that is produced by the voltage controlled oscillator is called as free running frequency. The VCO is an oscillator circuit, as the name suggests, in which the output frequency f0 can be controlled by an externally applied voltage. See, this frequency f0 can be controlled by the externally applied voltage. The VCO provides, see, this VCO provides the linear relationship between the applied voltage and the oscillator frequency. The applied voltage is called as controlled voltage. See, we can ask how this controlled voltage is produced. So we can look the operation here. We'll get the answer by looking its operation. Okay, here let the input signal of amplitude Vs and the frequency Fs be applied to the PLL. Okay, here the input frequency Fs and with the amplitude Vs is applied to the PLL, and here there is a first component. As you can see, there is a phase detector. What is the function of this phase detector? Here the phase detector compares the phase and the frequency of the input signal with respect to the phase and the frequency of the output signal. If there is an error either in the phase or in the frequency or both, then it gives the output known as error voltage. It gives the output voltage which is popularly known as error voltage. What does this error voltage contains? See, the error voltage contains some frequency signal Fs plus F0 and difference frequency signal Fs minus F0. This difference frequency signal Fs minus F0 is having the low frequency value, but of Fs plus F0 is having the high frequency signal. As we know that when this is passed through the low pass filter, the function of the low pass filter is to attenuate or block the high pass filter signal. Therefore, this Fs plus F0 is attenuated, and this Fs minus F0, that is the error signal, is passed through the low pass filter, and this error signal is then passed through the error amplifier. The function of the error amplifier is to strengthen the error voltage VE. Okay, after VE passes through the error amplifier, the output obtained is nothing but VE,
VC.
control voltage. What does this control voltage do? As I have said earlier, this control voltage controls the frequency of the output. This control voltage VC controls the frequency of the VCO F0. Okay, and finally we will get the F0. The control voltage signal varies the frequency of a VCO, that is F0, so as to produce the frequency difference between the Fs and F0. Okay, next we will come across the terms known as capture transient or capture range and locked. Okay, what do you mean by this capture range? As see, as soon as there is a value of difference between the, see, the range in which the value of the frequency is different from the input and the output frequency is known as capture range. See, whenever there is a difference in between the f0 and fs, that range of value is known as capture range, which is shown in this graph. Okay, next we are going to look at the term known as locked range or tracking range. See, the range of frequency over which see the range of frequency over which the PLL can maintain lock with the PLL can maintain the lock with the incoming signal is called lock-in range. Okay, this is one of the standard definition of lock-in range. Okay, that means here the output signal of the VCO, when it matches the input frequency fs, then that condition is nothing but lock in normal words. And the next term, the important term, is known as pull-in time. The total time, the total time taken by the phase locked loop to establish the lock is called pull-in time. This depends on the initial phase and the frequency difference between the two signals, as well as on the overloop gain and overloop filter characteristics. And this is the overall function, and this locked and capture range and all these conditions have been explained